Hello, I'm Patricia Lockney.
And I'm Jeffrey Wen.
And together we are MSEECE. And in this project, we're working on the detection and flagging of potholes while driving. So the motivation for this project, we want to make a safer driving experience following the Honda initiative. But first and foremost, approximately 33,000 vehicular fatalities occur each year, and 1/3 of those involve poor road conditions.
And currently the method for reporting these is either online or a call-in reporting, which can be really slow and cumbersome. So a lot of times it doesn't happen. So we wanted to automate this process so we can get those roads fixed faster and have safer driver experiences.
So our project goals, first and foremost, we want to improve safety conditions while driving. And we are trying to do that through the creation of a pothole/rough road sensor that monitors road conditions while driving, and also potentially records the GPS location of detected potholes and patches of these rough roads as they're detected in real time.
Yep. So with this, if we're able to flag the exact location of where these poor road conditions are, we can potentially upload this information to something like Google Maps, and that can give warnings to drivers that there might be a potentially dangerous road up ahead. But it can also help build up a database for the Department of Transportation to know where they should focus their attention and which roads they should repair sooner.
So in the first part of this project, we really wanted to focus on gathering some data on smooth versus rough versus roads with potholes. So we created a device which utilizes an accelerometer and an ESP8266 Wi-Fi module to detect and communicate road discontinuities. Here is our device.
Yep. So we have the Wi-Fi module and the accelerometer. And then from that point on, we just connected it to the center console of the car and went looking for potholes around Columbus. So this is some of the data that we collected while we were driving. In the blue, you can see is an example of a smooth road detection. And then over on the right, the signature of a pothole. And then at the bottom, you can see there's constant fluctuations, which correspond to a rough road condition.
Right. So here we're mapping acceleration in the Z axis. So you can see as we're going over a pothole, the overall acceleration in both directions heavily increases over that of a smooth road. And same for a rough road, but it just continues over a longer time period and more data collection.
So from there, we could then try to create an algorithm to detect these potholes and rough roads. And once we came up with an algorithm, then we wanted to integrate it into a Blink app. So that way we can communicate the real-time data to a phone, and we do that over Wi-Fi. And then with the app, we also added a map and GPS display so we can see where we're at. And this is some of the workings of it. So you can see if there's a quick motion, it says there's a pothole. And if there's continuous motion, then it says it's a rough road.
They're in the background.
Yeah.
Here's our data in real time with the map down at the bottom.
So then with the new system, then we went and tested it on a pothole.
Here in the background is an upcoming pothole that we're driving pretty slowly over. You can see we're jostled.
And then boom, there's a pothole. So in future work, we just want to integrate and record the GPS location in the database. And then we also want to potentially include the speed that we're traveling over these potholes to better refine the algorithm and potentially use machine learning to be able to classify these different types of roads. Thanks.
Thanks.